So our first speaker is Naledi Madlopa. He's gonna tell us how to divide and conquer with Android app modularization. Naledi is an experienced Android engineer with demonstrated history of working on the research industry and the banking industry, currently consulting at Standard Bank for Brighthouse as an Android developer and part of the insurance team, working on the vehicle asset finance, insurance, and kids banking products. So thank you so much for joining us, Naledi. Just show us how it's done. Thanks.
Hi, everyone. Does anyone have an idea what Android modularization is? Okay, you can go ahead, sir. You get it?
Well, I didn't know if I have to speak, but like you can create modules in Android Studio and then access those from different modules.
All right, cool. So let's break it down first. So in order for you to understand what to modularize an app is, or how to actually go about doing it, there's certain concepts that you have to understand. The first one is monolithic systems. So let's look at what a monolithic system is. So according to Wikipedia, a system that is called monolithic is a system which is functional, distinguishable aspects are basically contained in a single package, for instance, or a single module. So in an Android context, you know, when you create a project in Android, you always get that first module. So that's your default module, which is called app most of the time. So most of us, or most of us as Android devs, we've been through that where we're working with one application with one module. So those are called monolithic apps. So let's move on to what we call what a modularization app is. So in order for us to further understand what modularization is, we're going to look at modular programming. So according to Wikipedia, modular programming is a software design technique and that put emphasis on separating functionality of a program into independent interchangeable modules, such that each and every such that it contains everything necessary to execute only one aspect of the desired functionality. So, sorry, man. Hello? Okay. So what it basically means is, so with an Android app, so basically what an Android app is basically a collection of features. So it's a collection of features. So according to Wikipedia, how they define modularization, modular programming is being able to take your modules, your code, and separate it into different modules such that it is executable independently. So my belief or philosophy when it comes to Android modules is they have to be designed in such a way that you are able to plug out a module and be able to plug it in onto another app as well, because onto another Android app. Or if it's a Java module, then you need to be able to plug it out and plug it into a Java module as well. So that's my philosophy when it comes to Android modules, or just modules in general. So it's like an engine in a car. So cars are basically a collection of different modules. So you get your chasers, you get your steering wheels and controls, you get your engine and all that. So if you're driving a certain particular car, you need to be able to plug out an engine of that car and plug it into same type of car or same type of model of the car. So that's what modularization basically is, if you don't understand. And then, so let's look at how we'd actually go about modularizing an app in Android. So how do we do it? How to modularize an app? So basically, I spoke about monolithic systems. So let's look at the monolithic systems. Okay, before I go through that, I have the screen here. So in Android Studio 3.4, they've added a feature whereby if you're in a class, you can basically right-click on it and then go to the refactor menu, and then you'll see the modularize option there. So as soon as you click on that, menu, this dialog will show up here. So basically, this dialog allows you to be able to select whatever module. So if you have modules in your app, it allows you to select whatever module that you have you want to refactor that particular class into. So basically, this is moving out that particular class into that particular module. And if you only have like your base module, it's usually called the application module. So with that module, if you only have that one and you refactor a class, what you basically do, you are able to actually create a new module from whatever class you're extracting. So what Android Studio does for you is that it selects all related classes and resources that are related to that particular class that you want to modularize, and it gives you the option to actually move everything along. But this is not just automated. There is some manual work that you have to do, such as fixing your import statement and all that, and ensure that everything still works as expected. So let's look at how we would go about modularizing an app in the Android platform. So I spoke about monolithic systems. So basically, as I mentioned earlier on, we've been there as Android developers, whereby we have one application, one module, and all our code in there. And this is what we do right here. We start splitting out everything into different packages. We have the catch package, we have the data package, the model package, the UI package, widgets, and all that. That's what we do, right? It's not wrong, trust me. I know there's a lot of people who believe that systems or applications should always be modularized. But then when it comes to Android, I don't think it's necessary to modularize every app. So you don't just modularize an app. So how do you go about modularizing app? What's the reason behind wanting to modularize an app, basically? So when you modularize an app, there are certain benefits, and there are also cons to it as well. Disadvantages to actually modularizing an app. So say, for instance, you're working in a small application that does not require you to have an instant app or support the Android app bundle, the new Android app bundle format. So there's really no need to actually modularize your app there. You can have your monolithic app and have it working as you want. However, if you want to support instant applications or app bundles, or say for instance you just want to modularize your app because your code is your team is growing, the project is growing, and now things are getting funky in the single module application. So yeah, then you can start considering modularizing the app into separate modules in order for you to achieve separation of concern, basically. So that way you are able to separate whatever functionality into its own package and then use it as a dependency onto the application module. So this is what we have currently, right? So going back to the previous slide, that's not what we're going to do to actually modularize an app. Well, I'll show you how to go through it and how we can go about it. So, say for instance we have a monolithic app. So a common thing to do would be to modularize it, and then you have a modularized app, right? Whereby your catch package has turned into your catch module. And your data package is turned into a data module, your model package, and so on, right? And there you have it. Then you just use those as dependencies onto the application module, or the base module rather, right? So don't do this. I'll explain why. There are a couple of reasons as why you should not directly modularize your application based on your packages. Like I had mentioned earlier on, modularizing an application, basically you want that particular module to be able to stand on its own. So you don't want it to rely on another package to function except through interfaces. So you abstract the dependencies out. So let's look at the other problems that we might have with modularizing an app the way that I showed you on the previous screen. So secular modularization. So stated here in software engineering, a secular dependency is a relation between one or two modules which are either directly or indirectly related, dependent on each other to function properly. So looking at this diagram on the left here, so basically you'd have a package on package A, which makes use of a method or a class in package B, and package B makes use of a method or a class in package C. So basically that creates a secular dependency basically among the three packages. So between A and C, there's an indirect secular dependency, whereby A and B and C and B, there's a direct dependency, secular dependency there. So secular dependency can cause a lot of unwanted effects on a software program. And the most problematic from the software design point of view is tight coupling. So going back to the previous screen, most of the time what we do when we divide our app into packages is it becomes tightly coupled. So when you create data models, when you create your network layer and repo layers, they are specifically for that particular application. So it's very difficult to plug out your repository and plug it onto another application. So hence I mentioned that don't modularize your app directly from the packages onto the modules. As well, and again in software design, secular dependencies are considered an anti-pattern with a negative effect. And as well, the secular dependency can cause an abdominal effect on small local changes in one module, spreading onto modules that have unwanted global effects, such as your program errors and all that. And just to talk about this point here, this is actually what we experienced this week, I think for like 2 days at work, whereby, so what we have is a platform team which takes care of our core modules, like so a core module basically would be a module that contains the core of your applications, so such as your networking, your communication layer, your data layer, your login stuff, your session management, and all that. So basically, what we find ourselves in a situation where we have secular dependencies at the moment. So they were trying to fix that by extracting out some of the functionalities into standalone modules, and all the teams across the Android platform could not do work for close to 1.5 days. See, so those are the type of issues that you might come across when you do not do modularization properly. So let's move right along. So we understand what a monolithic app is. So basically that standalone application which has the application module, which is the default module basically, right? And then we now understand what modularization is. Just to recap, so basically modularizing an app is a process of separating functionalities into related code bases. And according to my belief, you need to be able to plug those modules out, right? So how should an app be modularized? If we're not going to do it from, if we're not going to take our packages and create modules out of those, how do we modularize an app then? That's what I want us to look at right now. So in order for us to understand how to actually modularize an app, we need to understand the different types of modules. So that's what I want us to look at right now. Different types of modules that are available on Android we can use to actually modularize your app. So basically the first one would be an application module. So an application module is the initial module that you get every time you create your Android application. So when you go a new project and it starts building and then it syncs, and then what you have there at the top of the at the top, if you're in a project Android view, you'd see there's a package there called app. That's your initial Android application. So if you open its build.gradle file, you'll realize that the first line would be the application of the application of the apply plugin. So basically, this is where you actually declare that an application, a module should be runnable. So if you have more than 2 of these in your project, then it means you have 2 runnable modules. So in some cases, you do find projects that require that. It requires a client-facing application and an administrator-facing application, for instance. Then you can apply this application in that particular build.gradle file for that module. So an application module is a runnable module, as I stated. So this module, these modules get added by default, as I stated. So everything that's written here, I've already mentioned. So basically, at this point, once you created your Android, your new Android project, this is what you get. You basically get your application model, your application module, and then in your application. So then we have core modules. I did mention a bit earlier on about core modules. So basically, a core module can be used to group related functionalities of the app into independent interchangeable modules, which are reusable. Let's mind that it has to be reusable, not particularly for your application. You need to be able to plug it out as well. So I did mention that as well. So separating functionalities can also help create a clear separation of concern that makes the code easy to understand, test, maintain across different teams. So I just want to talk about core modules. So there are 3 different ways to actually implement a core module. So for instance, let's look at this diagram at the moment. So basically here we have our code, our base application, which is the app module that I was talking about. So basically every time you start a new project, this is what you get. You get the default module, which is the application module. So as soon as you created a project, you can just run it, and it can build to your device or to the emulator. So now let's look at core modules. So I've grouped the core modules here we might require together here. So basically, say for instance, you want to modularize your networking functionality. So basically what you do, it depends on the type of approach you're going to take. So if you're going to use Kotlin, then you can use this line of code here instead of that apply plugin with that Android application. So you just apply the Kotlin plugin, and then if your module is going to be Java based, then you can just use your Java library plugin. And then so say for instance, because you can also modularize your UI stuff. You can also create a module to group out your Android code, like or Android or UIs, for instance. So say, for instance, in a situation where your app supports a mobile device as well as a wearable device, smartwares rather. So in that point, so each of them would have their own module in this layer here, whereby you are able to run your application on a phone. You are able to run it on a smartwatch, for instance. So those two can be separated out. You can separate the UIs out, and then the logic is going to be the same in most cases. You want the business logic to be the same. So what you'd want to do is take that business logic and you put it onto a core module, and then you can split out other functionalities of the app, such as the network, the data layer, and the commons layer. So most of the times there's also a commons module which provides whatever common functionalities that an app might use into different modules, basically. So in this diagram, what I have here is the data layer, for instance, is the data module. So this data module is dependent on a remote module. So this is where you actually get your data from a service call and so on. And then you also have a cache layer, where you can just catch whatever remote data you get and then catch it onto a local device. So let's look at another type of modules, which are feature modules. So as I stated, an Android application is a collection of features. So what a feature basically is, So what a feature basically is, it's a flow within an application. So there's a starting point in a flow, and there's an ending point in a flow, and there are certain screens in between. So let's look at feature modules. So feature modules, in order for us to understand different feature modules, we need to understand the type of applications we might have in Android. So there's a standard application which we have spoken about. So a standard application is one which does not have instant apps or dynamic delivery features. But however, However, you can still separate the features of the app into different modules and benefit from modularization. And this is what we spoke about on the previous slide, whereby you can pull out certain features of the application into the core modules. Then you can still have your standard application. In this instance, your library modules or your core modules can be used. Can be implemented using the Android library plugin. So what this does is, if your module has reference to the Android framework or makes use of Android functionalities, then you can use this one. And then if it uses Java, then you use that Java library, or you use the Kotlin plugin. So this type of design allows the app to be future-proofed in case it moves into instant applications or dynamic delivery direction. So that's the benefit of actually modularizing an app here, whereby you have your stuff modularized, even though you don't support instant apps or dynamic apps at the moment, but your code is modularized. So in the future, you are able to take certain features and actually modularize them. So sorry guys, I'm looking at the time, so I'm just going to try and rush through. Please catch up with me. So then we have dynamic support applications. So a dynamic support application is an application that uses the new app bundle, which allows individual features to be dynamically delivered to the user. So modules are used to decouple specific features and resources of an application into a module. So basically what you'd have is your base module, where in this instance it's that app module, and then you can have your feature module separated out into separate modules basically. So in your modules build.gradle file, you'd apply that dynamic dash feature. And then in your base build.gradle file, you'd have to use this tag here, whereby you specify that you specify all the dynamic features in the app onto the base module so that it can be able to reference it. So let's look at instant support applications. So in instant support, an instant support application is one that actually supports the Google Play Instant and requires modules to be able to add it. It requires that modules be added to use the feature plugin to declare them as features. So hopefully we can get to the demo, then I'll show you that how to actually do it, then it would explain it much clearer. So an instant application basically, in summary, it's an application that actually supports instant applications. So as I stated, a feature basically is a flow that from one start to one end basically. So as I stated again, an Android application has different features. It's a collection of features. So you are able to take that feature and create it as an instant application. So basically an instant application is an application which you don't have to install, basically. So you can use a URL to basically open it up, use it, and you don't have to install it. It does not stay on your application, on your device. So once you close it, that's it. So your project is able to have a couple of instant modules, which can then be used to actually go through certain features or flows rather. And however, you can also have an installed application. So the benefit of these are you don't have to install every feature, and I'll explain to you further. I'll show you scenarios whereby you actually use an instant support application, when to use it and how to go about doing it, the advantages, the disadvantages, and the current state in most applications. So let's look at instant app modules. So an instant app module is required in order for an application to support an instant app. I did mention that. So this diagram is the same as the one in the previous slide. So the purpose of an instant module is to consume the feature module that have been referenced in a dependency and simply build the instant app or on request. So therefore, these modules will be empty most of the time. So basically, if you're going to be supporting instant apps, what you'll realize is you're going to need a feature module. You're going to need an instant app module as well. So, and then, or if you have install apps, you can have that as well. And then you have your base module. So features would contain any code that's related to that particular feature. So say, for instance, you have a login feature in your application. You can pull that out into its own module, instant module, and use it along. Say, for instance, you have a feature you want to make instant. You can use that module, that login module, along with that feature to actually access the application and view whatever feature that you're viewing. So let's look at the scenarios in which you can actually implement these type of modules. So let's first look at dynamic delivery modules. So basically, we have Bank A here. So Bank A has a module which provides basically transitions. So basically, transitions in this module would basically be your day-to-day banking, checking your balances, sending money, depositing money into different accounts and all that. So that's basically, those are the core functionalities of every bank. You want to be able to save your money, access it, view your balances, transfer money to other accounts, transfer money to other people. That's that. So in a dynamic delivery application, basically what you'd have is, we must also recall, applications have what we call, banks have different products. So say, for instance, a bank offers your day-to-day banking stuff. They offer vehicle financing, they offer home loans, they offer insurance as well, right? So a dynamic application in that instant would allow you to be able to provide, say, for instance, I'm banking with Bank A. I'm not doing insurance with them. I don't have a vehicle finance with them. I don't have a home loan with them, right? All I need from them is day-to-day banking, basically, right? So an application should be able to provide me that. I don't need to download all the source code that I do not need onto my device, right? So what dynamic delivery does is it allows you to add certain features as you require. So for instance, you have this transition module here in your application. And then, say, for instance, I decide to, you know what, let me buy a car. Then I get it through the same bank that I'm banking with. Then that's when I can start adding that feature onto the app itself. So it dynamically adds the features as you need. So this is just an illustration using financial institutions, or rather banking institutions. So say, for instance, time goes by, I want to add I want to buy a house. I go through the same bank again. Currently, I do not need the home loans code on my device, right? So I don't need to add that onto the device. So, but later on, I decide, you know what, let me get a home loan. They approve it, or rather, after buying a car, you want insurance, right? So you get it through the same bank. Then you can add that module. So this is the feature-based modularization. So then you have, say for instance, then I buy a home then I can add that feature onto the application. Now all these features that you see here have been dynamically added as I need them. Not everything is all in there and they just feature toggle off couple of features, then I can use whatever that I'm using, but the code base is still on my device. Understand? So that's the whole point of dynamic delivery. And then let's look at instant apps. So here's another scenario here. You have bank B, you have bank A, bank C, bank B, bank C. All banks provide similar products. They all provide day-to-day banking. They all provide vehicle finance, home loans, and insurance. They all provide that. However, say for instance, I'm banking with Bank A, and I'm doing my day-to-day banking there, and I apply for car financing, and I don't get approved. So I decide to go to Bank B, and Bank B is like, hey, here's a new client. Let's bring him on board. They give me a vehicle financing, right? Then they tell me, hey man, we've got this cool app whereby you can monitor your vehicle stuff in there. It has a lot of features. Just download our app to monitor all those things. And yeah, I don't need to go to a branch, right? It's 2018. I mean, who wants to be at the branch in 2018? We can do these things online. So I'm like, cool. I download the app. Now I have two apps. Bear in mind, I have two apps with two different features. However, both these apps, because they're not modularized or they don't support instant applications, what do? They have all the source code in my device. So I don't need VEF from Bank A. I don't need home loans. I don't need insurance code on my device. Bank C as well. I don't need transactional code. I don't need home loans and all that. And then I decide, you know what? I'm not gonna get my insurance with I'm not gonna get my home loans with Bank B, with Bank A or Bank C. Bank A or Bank B, because Bank C gives me a better interest rate, right? So I decide to bank with them, and they tell me the same story. Hey man, we've got this cool app you can download. We have this cool app, and you can monitor all your home loan services there. You can also do calculations, check how much you've paid, how much is remaining, and all that. I'm like, yeah, I want to know all that information. Then they decide to download the app. So now I have I've got three apps with 12 features. And imagine all that source code on my device. I do not need all the source code in there, right? All I need is one feature per application, right? So because day-to-day banking is something that I do on a regular basis, I can have Bank A giving me a transactional feature as an installed application. I do that on a daily basis, right? So I'm able to access those type of features as I need and whenever I need them. But with insurance, with VEF, which is your vehicle financing, I don't need to always open it up and check how much I've paid. Maybe I might do it after a couple of months, after a month or so, right? So I don't need all that source code on my device at that particular time. So this can be turned into an instant application. So whenever I need it, I just get the link from Google Store, just try now, and then I'm able to check how my vehicle financing status is looking like. And same for Bank C with home loan services. You don't always want to keep on calculating every day how much is remaining, how many years, how much money money you can put in and all that, right? So this as well can also be turned into an instant application. So all I'd have on my device is this feature here, which is required to be less than 4 megabytes. So imagine the amount of space that I'd be saving on my application. And not just that, what happens in applications is there are certain calls or service calls that happen. So it also uses my data for features that I don't even need. So there's a call that happens to check whether I have a vehicle financing with Bank A. It checks that I have home loans and all that, right? It checks the products that I have with the bank. I don't need it to do that. I just need the app to do service calls that are related to the transactions that I want to do, right? So those are some of the issues that we might be facing currently with most apps, basically. So this example might be far-fetched, obviously. Like most of us bank with one bank. We get vehicle finance with one bank, home loans with one bank, insurance with one bank. You want to keep all your stuff in one bank. Most people prefer that. Some just don't care. Right? So in that instant, so this is what you would be looking for, right? All these. So as I had explained, you'd have your different features, but in some of them as instant applications. So instant application in this case would be this. So for instance, I'm doing everything with one bank. The bank, Bank A. So Bank A does not have to make everything installable. All I need is to have transactions installed. Then all of these I can use as instant applications, or I can use as dynamic delivered features, basically. So that's the scenario that I was explaining there. So here are some advantages of modularization. So some of the new tools from Google are aiming at modularized applications. So you might want to be mindful of that. In the future, there are certain features that you might not be able to leverage off. So basically, hence the talk is divide and conquer as well, whereby there are certain advantages you can gain from modularization, and not just from a technical perspective, but from a business perspective as well. Because if you look at the scenarios that we spoke about, if some of the apps were able to do that, I mean, like with an instant app, you are able to access that particular app, even if, say, for instance, you're not Bank A's client, and you realize, oh, this bank is actually providing cool features. Why don't I move to it? And then that's how it might also benefit the company. So, and again, modularization offers fast compilation time. So if the compile time is taking long, then with modularization, you are able to, in your settings Gradle file, you're able to remove some of the modules of your project. Then you can just compile whatever it is that you're working on at that particular time, which then increases your compile time. And then each module can be independently built, can be tested, and it can be easily debugged. So basically, with modularization is you have these different modules, right? So if I'm making changes on module A, I don't have to compile the whole application. I can just compile that particular module that I just changed. So that's the benefit as well. So it's easy to actually test it out and to debug if there are any bugs on it. And then also the separation of concern makes it easy to onboard new developers, as the separation of concern makes it easy to understand your code. So basically, so imagine a room full of books put however, and they're telling you that's going to be the library and you're going to be the librarian. So every time someone wants a book, you need to figure out where the book is, which session, it's not clear. So when you pull out one book, some of the stashes just fall on and all that. So what modularization allows you to do is to pack those books in proper shelves and nicely and according to certain sections. So it's easy, for instance, if a certain section is no longer relevant, to remove the whole section and put in another section as well. And then, and also a modularized application makes it easy to take advantage of the new distribution features that I had already mentioned, like your instant applications, your app bundles from Google. So disadvantages. So modularization has a lot of advantages, but it comes at a cost. And it's not for everyone. So as I had mentioned, you need to understand when you need to modularize before you understand how to modularize. And you also need business buy-in. You might not get business buy-in to actually modularize because it takes a very long time to actually modularize an app. It's not just a quick fix. It takes a very long time and a lot of effort to actually modularize an application. So, okay, I'm running out of time. Okay, I'm just going to skip the demo, guys. I wanted to show you the demo of how to actually implement the Android app modularization. So before I leave, I just want you to leave with this code, my favorite code that says, if we want users to like our software, we must design them to behave like likable people, respectful, generous, and helpful as well, by Ellen Cooper. So yeah, thank you guys. That's my time.